Hi, this is Tom Loschiavo, Chemistry Education Manager at Pasco Scientific, and I'm here today to talk about how you can use the Pasco spectrometer to do Beer's law analysis of solutions. So I have the Pasco spectrometer, Bluetooth connected to the computer, and I have a set of standard solutions and an unknown solution for my analysis. So after I pair everything, I'm going to go to the spectrometry program, and I'm going to go to Analyze Solution. So once the Analyze Solutions page is up, I'm going to have to calibrate my spectrometer using a blank. So I'm going to make sure the sides of the cuvette are clean. I'm going to put the clear sides of the cuvette towards the detector and the light source. And I'm going to blank my cuvette using a dark reference, which turns off the light in the spectrometer, and a light reference, which turns on the light to allow all that light through the solution, or through the solvent in this case, of water, the blank solvent. And after the calibration is complete, I'm going to hit Start, just to make sure everything worked correctly. And I see that I have an absorbance of 0, which is what I want for my calibrated blank. So now I'm going to take one of my standards. Again, clean the sides. Put it into the spectrometer. And I'm going to see the absorbance spectra. I'm going to stop recording. And I'm going to set the wavelength for study. I'm going to use my coordinates tool. And I'm going to drag that over to the region where I want to do my study. In this case, a red-orange region of the spectra with a relatively high absorbance. I'm going to hit check. It's around 656 nanometers in this case. So now I'm ready to do my concentration studies using my standards. So I'm going to go to the concentration tab in the software. So in this tab, it's set up for Beer's law. I can enter concentration values. It'll record the absorbance values. I'll see a live scan of the full spectrum of the absorbance from 380 to 950 nanometers, or whatever region I've selected. And I'll be able to determine the unknown concentration using this separate table down here. So to get started, I'm just going to hit Start. And in this case, it actually is 0.2 for the concentration. So I'm going to hit Check to save that absorbance. I'm going to put in my next standard. I'm going to wait for that to stabilize. And I'm going to hit Check. I'm going to change the concentration value to 0.14. I'm going to go to my next solution. I'm going to again wait for that to stabilize and hit keep the value. And I'm going to change the concentration for that, which was 0.08 molar. And I'm only doing 3 standards this time, so I just have those 3. And now that I'm set, I'll hit Stop. So I can see my points down here. I can auto-scale that graph and see those points line up. I'm going to rescale it a little bit so we can see the graph and the full spectra better. And I'm going to apply a linear fit to that. So down here are some tools. I'm going to show a linear fit and move this out of the way. And I can see my linear fit with the slope, the intercept, and the R value of 0.999. So pretty good fit for those concentration and absorbance values. So now that I've calibrated my standards, I can determine the concentration of an unknown based on its absorbance and the information that I have. And this is where the software allows for some, or incorporates some pedagogy. So if I put my standard in, and I go down to my unknown concentration portion of this page, I click in absorbance and I hit Start. Now it's going to measure the absorbance of the unknown, and I'm going to hit Keep. And it doesn't tell the student what the value of the concentration is. It doesn't put it on the graph, but you can put it on the graph. The student has to figure it out first. So based on that absorbance, I can look at my data table. I can use the calculations of the slope and the intercept, or I can even use the graph and try to figure out what that concentration would be, what that unknown concentration would be. So after I think about it and look at everything, I assume the concentration is about 0.1. And now that calculated concentration of the unknown is now plotted on the graph in a color. And the color actually gives the students some clue about how well their predicted value of the unknown fits, or calculated value of the unknown fits with the information that they have. Green means that everything went well and their concentration fit on the fit line very well. Yellow means that they're close, but they might need to recalculate. And red means that they're very far off and they're sort of just guessing at that point. But pedagogically appropriate, it allows them to create the curve based on the standards, to analyze an unknown, and there has to be some work on the student's part to figure out what the concentration of that unknown is. And they get some feedback of that using the software. So I'm going to stop data collection. So this has been doing Beer's law analysis using the Pasco spectrometer. Thank you very much. This is Tom Loschiavo. If you have any questions or comments, please reach me at chemistry@pasco.com. Thank you.